Okay, so this is practice one, interaction diagrams. And we are going to go through each of these scenarios and kind of take a look at what are the interactions that are happening here. Okay. So always when you are doing these, we are going to make sure that you are always drawing in earth. Okay, so you need to add the earth. All right. So we've got 3 acrobats hanging on or creating awesome shape right here. And we have earth. That's happening here. And I drew the floor in just so we could probably see it a little bit better. Okay. So we've got acrobat number 1 that is having a normal force with the floor, and the floor is pushing back on acrobat 1. So we'll just label this one 1. This is acrobat number 2 and acrobat number 3. All right, so acrobat number 1 is supporting the acrobat number 2 by pushing on the acrobat, and acrobat 2 is pushing down on acrobat 1. So that's a normal force. We've got acrobat 2 pushing down on 3 and 3 pushing back on 2, and that is also a normal force. And acrobat 2 does not have an interaction with the floor, so we're not going to draw one, but acrobat number 3 does, so there's an interaction with the floor there. Okay. And so now what we're going to do is draw like a system diagram on the other side. So system diagrams, if you remember from the energy unit, you had to draw each of the objects inside their own space, and then we're going to show the connections with each other. All right, so we're going to go ahead and do that. So we've got Earth, and then we've got acrobat number 1. Okay, we've got acrobat number 2 and acrobat number 3. Okay, so acrobat number 1 gets their own circle. Each object needs to be in their own bubble. Okay, and we've got, you can also include the floor if you'd like. All right, so there's the floor. Okay, so acrobat number 1 has an interaction with the floor, and that is a normal force. Acrobat number 3 has an interaction with the floor, also normal force. Acrobat number 2 does not have, so acrobat number 2 does not have an interaction with the floor. So there will be no interaction drawn between the floor and acrobat number 2. However, acrobat number 1 has an interaction. Acrobat number 2 and 3 both have an interaction. And all of these objects have an interaction with gravitational. Okay, so acrobat number 2 and Earth has a gravitational. Acrobat number 3 and Earth also has a gravitational. Okay, so that is our interaction diagram for the acrobats. Okay, I'll go through some of them, and I do want you to draw your own system diagrams. I know this part was for homework, so that should have been completed. And this part is the new stuff, and that's what you're going to be doing. Okay. So now with the flower vases, don't forget to draw on the earth. Okay. And we've got some interactions here. We've got the floor and the table. There's a normal force between them. The vase or the mason jar with the table, there's a normal force. The flowers inside the vase, okay, that's also a normal force. And since nothing looks like it's moving, we can just we can assume that nothing is moving and there's no sliding that's happening. Okay. We've got the floor and the earth, table and earth, vase and earth, flowers and earth. So that's the flowers. And now we've got this person pushing a box across the floor. Okay. So now there is some movement. The person is pushing the box in the direction, the left direction, and it's on the floor, and the man is also moving along with the box. So first things first, we need to draw our earth. Okay. We have our we've got our box that is on the floor. Okay, because it's not floating, and it is also pushing down on the floor. But the interesting part here is that because the box is moving, there's some sort of sliding interaction. It's not a static, it's dynamic. There's movement. So the box is sliding across the floor. And so we will say that there is a friction interaction or friction force between the box and the floor. Okay. We've got the hands pushing the box here. And we'll assume that the hands aren't sliding up and down the box. So then we'll just say that the box is being pushed by the hand. And then the hand is also pushing the box. And the box is pushing the hand. Again, remember that we talked about how the interactions, it's two ways, right? It's not just a one-way interaction. And so we've got the man the person that's sitting on the floor and the person that's also sliding against the floor. Okay. All right. So we'll draw the interaction diagram for this. We've got the earth. We have the floor. We have the box, and we have the person pushing the box. Okay, and I think those are the only objects, right? We've got the earth, we've got the box that's over here, we've got the person, we have the floor. Yeah, that should just be 3. Okay. We've got the box that's sitting on the floor and normal force, and the box that's also having a separate interaction with the floor at friction force. The person that is on the floor and the person that's also having a friction force with the floor. Okay, and then the person that's pushing the box. And then we've got the box with the gravitational force, the floor with the gravitational force, and also the person with the gravitational force. And then this would be considered a complete interaction diagram for this problem. Okay. Let's look at the trains. All right, so we're going to draw the earth. Okay. We see that the train is moving on the tracks. So each of these box cars will have a normal force with the track, right? So each one will have a normal force with the track. But since it's moving, there's also some sort of sliding, a shearing interaction that's happening with the floor, or with the tracks, excuse me. So there is a friction force that's also between the box cars and the track. Okay. And then, of course, everything has an interaction with the earth. Okay, and what I want you to focus here is that you really want to make sure that the endpoints are between the two objects in question, right? So we've got the train car and the earth that's interacting, and so the endpoints of each line is well within the objects. Okay, and so that is the first page. And then for the second page, I'd like you to do the same thing. Okay. This will be due next class, and then we will be whiteboarding it and having some discussions. But please make sure you have the pages complete before you come to class, even if you have questions, right? So I want to see this that's completely filled out. All right, that's it for now.